Good morning, students. To come to today's class, due to some reason, actually, I have to take your class through Google Classroom. Okay. So, exercise 8.1. Exercise 8.1, question number 5. Very important question. Question number 5 is given that in case of any quadrilateral, suppose the diagonals are equal and they are bisecting each other at right angles, then that quadrilateral must be a square. So this question is the reverse of the question number or converse of the question number 4. Okay, that means in question number 4 all of you solve that in case of a square the diagonals are equal and they are bisecting each other at 90 degree or right angles. Okay, so in this question it is asking that if in any quadrilateral, suppose the two diagonals are equal and they are bisecting each other at 90 degree, then that quadrilateral must be a square. Okay, so how can you prove this one? To be a square, a quadrilateral must have all the sides must be equal and all the angles must be equal. That means equal to 90 degree. Okay, but I think all of you know that in case of any parallelogram, if one angle is 90 degree, then all the angles becomes 90 degree. Okay, and that be a rectangle. That means that is the one example is given in your book also. So suppose in this case let us consider a quadrilateral ABCD. Suppose we consider a quadrilateral ABCD. Okay, AC and BD supposed to diagonals. AC and BD supposed to diagonals intersect or bisect at the point O. Okay, this angle is 90 degree. At first, we will prove that ABCD is a parallelogram. Okay, and after proving parallelogram, we will prove all the sides are equal. And if one angle is equal to 90 degree, then automatically all the angles becomes 90 degree, and that will be a square. Okay, so you can prove all the sides are equal. And all the angles are equal in a long way also. So let ABCD be a quadrilateral whose equal diagonals AC and BD bisect each other at right angles at the point O. Okay, to prove that we have to prove that ABCD is a square. Okay, so after writing this we are going to prove section. So you can prove, already I said you can prove it in two different ways. One, you can prove all the sides are equal by proving all three triangles congruent, and in one case you can consider a parallelogram also. So suppose at first you take these two triangles, proof. Okay, in triangle AOB and triangle COD. At first you consider triangle AOB, this one, and COD, this one. Okay, in this triangle AO is equal to CO, given because they are given that diagonals are bisect. Bisect means this part and this part equal, again this part and this part equal. Okay, again look at the angle AOB is equal to angle COD. All of you know this one is the vertically opposite angle. Okay, vertically opposite angle actually, and if this one is 90 degree, this one is also 90 degree, also 90 degree, also 90 degree. All four angles actually 90 degree, but you can say here vertically opposite angle. Okay, again BO is equal to DO, which is also given. So that means triangle AOB congruence triangle COD, and the criteria is SAS. And if two triangles are congruent to each other, their corresponding part must be equal. That means AB is equal to CD, which is CPCT. We can take number 1. That means we'll use this thing. So we write above here, AB is equal to CD, which is number 1. Okay, that means these two sides are equal. Again, now you can write, if these two triangles are congruent, that means this angle and this angle is also equal. Again, angle, you can write OAB is equal to angle OCD, which is CPCT also. Okay, if look at this one, OAB and OC, these two angles are alternate interior angles. That means AB and CD must be parallel. So you can write which are alternate interior angles. So therefore AB must be parallel to CD. Can give number 2, this one, AB parallel CD. Okay, so that means from 1 and 2 you can directly say that ABCD is a parallelogram. Okay, you can think that in case of parallelogram, actually diagonals are bisect. Okay, but you cannot use that identity, because again all of you know that in case of square, diagonals are equal. Already you proved in case of square, diagonals are equal and bisect each other at right angles. But in this case, this thing are you going to prove? Okay, so I think all of you okay, after writing this you can understand. Now from 1 and 2 we get, from 1 and 2 AB is equal to CD and AB is parallel to CD. All of you know in case of a quadrilateral, if two opposite sides are parallel and equal, then that quadrilateral must be a parallelogram. You get ABCD is a parallelogram. All of you, I can think that in case of a parallelogram, diagonals are bisect, then why we prove this one? Why we are not using this one? Okay, in this question you cannot use these things because we are going to prove this one. Okay, so ABCD is parallel. So parallel, that means opposite sides. In case of parallelogram, all of you know that opposite sides are equal. That means AB and BC is also equal. AB is equal to BC. Okay, opposite side, or you can opposite side of parallelogram ABCD. Okay, you can directly prove this one, or you can prove by proving these two triangles are congruent also. Okay, so AB is equal to BC, which is number 3. Okay, so now you are just prove these two triangles are congruent. Now you just prove these two triangles. Okay, now in triangle AOD and triangle COD. So AOD this one and COD this one. In this case, AO is equal to COD then, and triangle AOD is equal to angle COD. Both are 90 degree. Already we discussed that diagonals are bisect at right angles. So bisect at right angles means if one angle is 90 degree, linear pair must be 90 degree. Again, if this is 90 degree, vertically opposite this one is 90 degree. Again, this one will be 90 degree. Okay. So again, OD is equal to OD, common side. Common side. So therefore, triangle AOD is congruent to triangle COD, SAS. So therefore, AD is equal to CD, CPCT, and you just give number 4. AD is equal to CD, number 4. Okay, so now look at 1, 3 and 4. So look at the number 1, 3 and 4. 1, according to 1, this one is equal to this one. According to 3, this one is equal to this one. And according to 4, this one is equal to this one. That means from 1, 2 and 3, 1, 3 and 4, we get all the sides are equal. So from 1, 3 and 4, we get AB is equal BC is equal CD is equal DA. That means ABCD is a parallelogram with all the sides are equal. Okay, that means it may be a rhombus, it may be a square. Now, because in case of rhombus, actually diagonals are not equal, but we are going to prove. Okay, so that means all the sides are equal. Now we are going to prove that one angle is 90 degree. That means if one angle is 90 degree, then all the angles are equal to 90 degree because this is a parallelogram. Okay. So yes, now after that you just prove these two triangle congruence. These two triangles. Now in triangle you can say ABD and ABD and then BAC you can write ABD and BAC. This one is ABD and this one is BAC. So ABD and BAC, you can say that ABD, in case of ABD, AD is equal to BC. Already proof AD equal to BC from 3. From 3, okay. Now another thing is look at AC and BD equal. Diagonals given. That thing we are going to use here. Okay. AC you cannot write BD equal to AC. So from this triangle you can write BD, and from this triangle you can write AC. Okay, you cannot, because we are taking the triangle ABD first. You get ABD and next one is BAC. So from ABD BD you can choose, and from BAC AC you can choose. Okay. Given, and another thing, look at this, AB is equal to BA, common side. This side AB is in case of triangle ABD, and BAC we can write BA. Don't write AB is equal to AB because corresponding parts, that means AB is in case of triangle ABD and BA is in case of triangle BA. Same side, but you can write in a proper way. Okay, so common side. So therefore triangle ABD is equal to, so congruent to triangle PAC, which is S, and if two triangles are congruent, their corresponding parts must be equal. That means we can say that angle BAD, that means this angle is equal to angle ABC, okay, which is CPCP. Okay, but all of you know that already we discussed this parallelogram. That means this and this are parallel. This one is a transversal. That means these two angles are co-interior angle. Angle BAD. Look at this one B. These two lines are parallel. This one transversal. That means these angles are co-interior angle. Okay, but BAD, you can give this one number 5. BAD plus ABC. BAD plus ABC is equal to 180 degree. Within bracket we have to write co-interior angle. Co-interior angle. So that means in case of ABC, we can again write BAD equal to 180 degree. Just write using 5. Using 5. So 2 BAD equal to 180 degree. So that means BAD equal to 90 degree. So therefore BAD is equal to 180 degree divided by 2. So BAD is equal equal 90 degree. Okay, that means in case of ABCD as a parallelogram, already we proved one angle is 90 degree. That means all the angles must be equal to 90 degree. Okay, so therefore in case of ABCD quadrilateral, we are proving that AB is equal to BC equal to CD equal to all the sides are equal. Now we are proving all the angles are equal. So therefore ABCD is a square. Okay. So long question but very important question, and you have to write all the things. Otherwise marks will deduct, 1 or 2 marks will deduct if you not proving you are not proving all the main fact, then 1 or 2 marks will deduct. Okay, some students actually not proving the ABCD is a parallelogram. Okay, if ABCD, you cannot mention that ABCD is a parallelogram, then you have to prove all the angles are 90 degree. If you mention that ABCD is a parallelogram, yes, already is a parallelogram, but you have to mention this one that ABCD is a parallelogram. Then if you prove one angle is 90 degree, then automatically it will follow the criteria. That means in case of a parallelogram, if one angle is 90 degree, then it is then all the angles must be 90 degree. Okay.